Good morning, everyone. I am Samyak, and my roll number is 22011A0303. Our teacher is Mr. G. Raju, Assistant Professor from AAA Department. Today, I am going to be discussing losses in transformers. As we all know, transformers are a device which have one primary coil and two secondary coils. And in between these primary and secondary coils, there is a core material. Now, this core material can be iron or some other kind of material as well. Let us see what the losses can be of. The losses can be core, copper, stray, dielectric, and eddy and hysteresis loss come under core losses. As you can see, eddy current loss and hysteresis losses come under iron or core losses. Let us start with iron or core losses because it is the most significant loss that can occur in a transformer. The iron or core losses occur due to the inherent magnetic properties of the core material. You see, the core material itself has certain magnetic properties. Iron is having a ferromagnetic property. And due to this property, it can cause a loss because of the variations in flux generated when current is flown in the primary coil. Now, how it can occur is eddy current losses and hysteresis losses, which we'll look at in detail. Eddy current losses. Let us first understand what eddy current is. Eddy current is that current which is induced because of a magnetic flux, and it opposes the direction of current that is already happening, or the direction of current that we want. In simple words, eddy current opposes our needs, and hence it is considered a loss. It is induced because of magnetic flux. As you can see, magnetic flux induces opposing current called eddy current, and this eddy current causes a loss to the current that we are providing. How can we minimize this eddy current loss? We can do that by laminating the core of the material, and that is how we can minimize eddy current losses. Coming to hysteresis loss. Hysteresis is an effect wherein when we magnetize and demagnetize a material, it does not follow the same path of flux density and magnetic force. As we can see on the y-axis, we have flux density, on the x-axis, we have magnetic force. When we try to magnetize a material, it follows this path initially from zero state. And then when we are demagnetizing it, it follows this path and goes from A, B, C to D. And when we try to remagnetize it, instead of going through the same path, it will follow a different path. And because it follows a different path, the flux density and magnetic force do not correspond. And this gap that they form, is a loss. In other words, we can say that the area that this curve represents, that is present under this curve ABCDEF, is the loss, the hysteresis loss. And this keeps happening over and over and over again because the current is, altering, and hence core losses. This is what make core losses the most significant. One is eddy current losses and the other is hysteresis losses. Next, copper losses. What is the one other main component of a transformer apart from the core? Apart from the core, the main component of a transformer is the wire itself, the coil, the primary and secondary coil. And what are these coils made of? These coils are made of copper. Now, the loss that these coils cause are hence called copper losses. Now, how do these coils cause losses? You see, these coils, let me just, yeah, you see, these coils uh, these coils that are made of copper. As we all know, the heat generated from a current flowing through a wire is I square RT. And this heat generated is nothing but energy which is lost. And since it is lost, it is a loss. And the loss due to the current flow in the wire is represented by I square RT. Now we have two coils, actually three, because we have one primary coil and two secondary coils. And in these three coils, the total loss can be represented by this formula. W is equal to I square R of primary coil and I square R of secondary coil. And how do we reduce this kind of loss, this copper loss? To reduce this kind of loss, we can use wires which have higher conductivity. Okay. Now, I square R is, as you can see, the loss is directly proportional to I square, and I square is current, and current is directly proportional to the voltage difference. From Ohm's law, we know that voltage is directly proportional to current, and voltage is also called the load. And that's why we say current depends on the load. And since it is depending on the load, copper losses can be called variable losses because the load can be varied, and because of the varying load, the current is varying, and because of the varying current, we have varying power losses, varying power wasted losses. Next, dielectric losses. What we have discussed until now, core losses and copper losses are major because they are a part of they are the huge part of losses. Dielectric loss is a minor part. As you can see, it is written negligible compared to core losses. So compared to core losses, dielectric losses is very less. Now, as you already know, dielectric itself means the oil or the solid insulations that are present inside the transformer. And dielectric losses can occur when the oil gets deteriorated, the quality gets deteriorated, gets dirty, the pollutants get inside, and if the seals are not shut tightly, and even over time, the oil gets deteriorated and the solid insulations might get damaged. And because of these damages and the deterioration of oil, dielectric losses do occur. Moving on, stray losses. Stray losses are every other kind of minor loss. It is in a practical scenario, stray losses occur because of the sheer practicality of it. You can see that due to presence of leakage field in tank walls, stray losses occur, and they're very negligible. They're very very small, but they do exist, and we need to know that no matter how small the loss, they exist, and they can be minimized by splitting the conductors into small strips. As you can see, they have split the conductors into small strips. By doing so, we can minimize stray losses. These were the all the kinds of losses in a transformer. I hope you have understood. And copper core loss, let us once revise. Core loss is the huge, biggest chunk of losses caused in a transformer. Then comes copper losses, which is significant but not as significant as core losses. Stray losses and dielectric losses are very minor losses. Thank you, everybody.